Let's just jump right into it. They're just solving. They're just going. This would be, hey, there's your derivative. It's what we call the algebraic definition of a derivative. This is the pain in the ass way. You're almost there. We finish up chapter 2. You never have to do this crap again. Alright, we're towards the end. Let's go. Let's go. We want to go find this derivative here for 4 over the square root of x. Now, if you've done your 2.7 homework already, you've already messed with finding the derivative on the square root of x quite a bit. So I'm going to mix this one up. Make it a little bit more. Both these problems are going to be algebraically dense to get you ready to be able to do your homework problems, because you got to be a beast in algebra. So here we go. We're going to go find f prime of x the long way. So it's the limit as h tends towards 0 of our f of x plus h. And maybe we just go get our f of x plus h right at the beginning. We're like, well, let's write it off to the side so we can just replace stuff. There it is. Oh, found it. So our f of x plus h is just 4 over the square root of x plus h. And then we're going to subtract out our 4 over the square root of x. That's our f of x. Divide it all by h. Sweet. Let's get it. Let's go get it. Algebra time. So I think I'll common denominator it. What the hell? Why not? So let's give it a root x and a root x. Let's give this one a root x plus root h. X plus, or root x plus h, root x plus h. Right? Just multiplying by 1. You know how you add fractions. Take our limit as h tends towards 0. Leaving that h down below. We're not messing with that thing. And now we have that common denominator. That root x times root x plus h all over. And what's up top? What do we got? That 4 root x minus 4 times the square root of x plus h. Dang. Doesn't seem like it really did anything. Gosh, I wish it would have. Well, let's play a game real fast so we can start to clean this up a little. We don't like complex fractions, so we're going to use the idea that dividing by h is the same thing as flip it over and multiply by 1 over h. So now that thing's gone. Did you catch that? Or did you have that down yet? Get this freaking down. Dividing by h is the same thing as multiplying by 1 over h. This is the same thing as this. So we can't do both of them in the same problem. I'm just showing you that that's where it's going to go. So when I rewrite it, all that's going to happen is an h is going to pop up right in this denominator. Okay. Moving forward. The limit as h tends towards 0 of 4 root x minus 4 x plus h all over h times the square root of x times the square root of x. Jeez, what is he doing to us? What a jerk, huh? What a jerk. There's so much happening here, and you're like, dang, where are we going? Well, how do you think we might handle this when we have square roots up in a problem we handle a limit? Well, I think maybe we should multiply by a conjugate. But do you see something? Do you see that there's a 4 right here and a 4? I'm going to actually factor this all the way out to the outside. And I'm going to use a limit law because I want to remove noise. That's just going to leave us with root x minus the square root of x plus h all over h times the square root of x times the square root of x plus h. Okay. See how you can do that? Just factor it to the outside. It's a constant. That's the constant multiple rule. Now it's just a little cleaner when we go to do this. There's less noise. When we go to multiply by its conjugate. Okay. So we're going to end up with that 4 times the limit as h tends towards 0. And it's like, oh my gosh, are we putting more stuff down that damn denominator? We are. But we're only going to worry about putting these two together. Our a minus b times our a plus b, which is going to become x minus the square root of x plus h. All over, and just write it all down. Just write it all down. Don't put that shit together. Don't do it. Don't do it. All right. Woo, doggy. Look at us go. Now I'm going to cheat. You got a pencil? Do you got a pencil? I'm going to cheat. This needs to go into both pieces. I'm just going to, I don't want to write that shit again. So watch it. Here it goes. Whoop. Oh, there we go. Ooh, we did it. So I don't have to write all these frickin' steps. And now we're just left with our x minus x disappearing. And again, I'm going to cheat because you're watching me right now. I'm just going to let them disappear. Because I don't want to rewrite it. That's your job. I'm old. I got carpal tunnel. I don't actually have carpal tunnel. But I could. I've done a lot of math in my life. And what that does is after you've done all this work, there go the h's. Holy moly. Holy moly, that's so much. So we have 4 times the limit as h tends towards 0 of that -1 hanging out up top, and you got the square root of x, the square root of x plus h, times the square root of x plus the square root of x plus h. You know there's no more domain issue? Think about it. What happens if all the h's disappear? That's not a problem. So we're going to write it that way. We're going to write it as all of the h's are going to disappear. We got our -1 up there, so we have the square root of x times the square root of x plus nothing, right? They're all disappearing. And then we're going to have the square root of x plus the square root of x plus nothing. They're all disappearing. Oh, since they're disappearing, why did I write a limit? Because now we're plugging in that plus 0, where they all just disappear. The limit's not needed any longer. All right, so they all disappear because you're plugging in absolutely nothing. We clean this up and we go 4 times -1 is -4. Square root of x times the square root of x is equal to x as far as I know. And then how many of these do we have? How many of those do we have? We have 2 square roots of x. There's 2 of them, all right? One of them plus another one of them gives you 2 of them. Let's just do a little bit of house cleaning here. Cancel that out and leave it with the 2. And what have we got left over? -2 over x times the square root of x. Howdy, huh? Little derivative. Look at how many steps that was. Where'd I lose you? Did you keep up? Dang, I don't know. I didn't do well with these. I had to do a lot of practice, especially because there's not many numbers. There's like a lot of letters and shit in this. Okay. Well, can I give you your quiz now? Let me give you your quiz. This is 2B. I gave 2A in class on Monday. So let me give you 2B. Let's go find what let me think. Quiz 2B. Okay. You have to show all your steps. This is the point of this thing. For f of x equaling to the square root of 2 minus 9x. Let me zoom in. F of x equals the square root of 2 minus 9x. I would want you to find f prime of x by using the same methods I just used, by the algebraic definition. Algebraic definition of the derivative. If you just give me an answer, I'll give you no points. If you use any of the derivative techniques that have not been taught yet, I'll give you no points. The whole idea here is I want to see you do the algebra. I want you to do what I just did. Now, quiz 2B is going to be due. This is going to be Wednesday night before your exams. So Wednesday night before your exam, the 17th, 6/17 at 11:59 p.m. There it is. That's Wednesday night before your exam. Your exam 6/18. So there it is. Go find that derivative by the algebraic definition of the derivative. All right. So the same way we just did that one. That one's yours. Okay. I'm going to handle this one here. These are a pain in the ass. You have one of these in your homework. Let's go. Oh, shoot. G prime of x is going to equal the limit as h tends towards 0 of, now it's going to be 2 somethings minus something 4 minus somethings all over minus 2, oops, right, because our formula here is going to be g of x plus h minus g of x all over h. That's what I'm plugging into the limit. So instead of writing in x's, we'll write in x plus h and x plus h. And of course there's an h in the denominator. Holy moly, algebra! You cannot be successful in calculus without solid algebra. For a lot of us, this will be one of the biggest problems we've ever tackled before. Bear with it. And for some, you know, those jerks that always seem to know how to do things. I know. All right. We want to create a common denominator, so I'm just going to clean it up a little bit. 2x plus 2h minus 5 on top of 4 minus x minus h. I'm just distributing in the negatives. I'm just getting rid of the parentheses. And up top, we're going to be left with 2x minus 5 over 4 minus x. There's an implied parenthesis when you have a fraction sitting here like this, okay? So please beware of that. That is big. So now we have options. We can create a common denominator and solve this thing out. Or we can multiply everything by the least common denominator and just get rid of all of our complex fractions. I'm going to do that method this time because I've not been doing it, so this is a new sort of method. Our least common denominator is going to be 4 minus x minus h times 4 minus x. That's just taking the two denominators that we have that aren't 1, the one that's not 1, putting them together to guarantee we're going to fraction bust. But if we multiply on top by it, we must multiply down below. This is our magic 1. Right? Same picture over same picture creates a 1. Now as this travels in and as that travels in, things will cancel. And I'm not going to show all these steps. It's up to you to follow it. As this comes into this term here, to this term, that's going to cancel with that, only leaving you with 2x plus 2h minus 5, and it's going to be multiplied only by the 4 minus x, the piece that did not get canceled. Next, we're going to bring it in over to here. But now our 4 minus x's are going to cancel, only leaving us with our 2x minus 5 times the 4 minus x minus h. All over. Now in our denominator, we got all that stuff. H times our 4 minus x minus h times our 4 minus x. So you might like that method a little better than adding fractions. You can do that each and every time. Oops, let me keep my steps for just a second. Okay, now you might even want to use box method on this because we're about to have to go through this and not make a mistake by expanding it all the way out. So I'm going to pause you and just come right back with it. Sorry for the jolt there, but I didn't want you to have to watch me do all that and waste your time. That is the complete expansion. After all of that, we can go through and start looking. Positive 8x, negative 8x. Negative 2x, I don't have anything yet. Oh, there's a positive 5x, there's a negative 5x. What else we got? We got a negative 20. We got ourselves a positive 20. I wonder where my negative 2x. Oh, that's supposed to be a squared here. I made a mistake. And there we go. There's our negative 2x squared and our positive 2x squared, which will just leave us with stuff with h's in it, because that's how these things are always cooked up. There go my dogs. I'm powering through. And then we're left with just this. Sorry about that. Everything just with h's left over. So we go through, we factor out our h, because the whole game, the whole time we do these is always just to get rid of that little h. So we factor out our h to the front, and that leaves us with 8 minus 2x. Whoa, why am I doing that? Is anybody screaming in their head going, will you just cancel that shit out for me, please? Sorry about that. Sorry about that. Yeah, that was pretty good, huh? And then 8h minus, oh gosh, 8h minus 5h. Do you know what that was? That's just 3h. Oh, oops. Everything cleaned up so nicely. Did you catch all of that? Did all this just canceled straight away and it just leaves you with 3 over and you got your 4 minus x minus h all over 4 minus x. Now we can plug in our h is equal to 0 and we're going to find out that we can plug in our h is going to 0 right there for our h and end up with 3 over 4 minus x minus absolutely nothing times 4 minus x. Oh, that's a 4, by the way. So that gives us 4 minus x all squared underneath. And we have 3 over 4 minus x all squared. Wow. That turned out pretty freaking convenient. That wasn't so bad. Okay, maybe it was pretty bad. Sorry about such a long video.